Hello everyone. What is knowledge? And this is the age we call it as the age of information. How do we find out things? Often it is by somebody else teaching us what is through education, school, or at home. And society, parents, teachers, friends, they all kind of infuse our brain with so much of knowledge. What if there is nobody else to teach? Or what if we are interested in something and we don't have a way of finding it out? What kind of approach would we take then? So for that, it is we meeting other people and they wouldn't also know, just in case. And then how would we try to figure it out? That is what we will learn today. And it's about this scientific thinking. As Rosalind Franklin says, my method of thought and reasoning is influenced by a scientific training. If that were not so, my scientific training will have been a waste and a failure. Especially to be trained as thinkers, independent thinkers and scientists, following the methods of how to derive information is much more useful and are actually important. Hi everyone, I am Dr. BCMR. So we will discuss a bit of things, a little bit, a small demonstration. It's not an extensive lecture on scientific method, but simplistically, how can we approach it? We are talking about the scientific method, the observation. We first make observations, then we look into it, make more, or if the information is available, we'll research on the topic and then build an hypothesis and test with an experiment. For that experiment, again, we need to have the design of experiment and then analyze the data and then report the conclusions. And then we can probably take this up many times further. And that way we can always figure out the kind of information that we require about something, about the thing that is unknown to us. So we can also, we use hypothesis-based approach for most of the problems that we encounter if we didn't have prior knowledge or anybody's help. So I would want to bring in, I will also talk about this. I hope I'll be able to demonstrate this, and let's have a look at that. I hope you can see this. It is obvious that it is a magnet, right? It looks like a magnet, so it must be a magnet. Is it still a magnet or not? How would I know that? So the hypothesis, or my observation is there is a circular dark thing, and assume that I don't know anything about the magnets. How do they look? And I just want to think, probably, if I want to know, it looks like a magnet, but I don't know if it is a magnet or not. Then I can probably get into testing it. So the simplest way is to test is by using something, a metal one, and trying to touch it and say it is now binding. Therefore, it is a magnet. But then what if somebody has come to you and argued that there is some glue on the surface of this, and that is the reason why it has attached to this thing? Just for the sake of argument, you can come about into scenarios when we have debates about something, and this is one of the perfectly all right counter argument, that maybe this has glue on top of it, or maybe this one, the ring that I have, has glue on top of it, because of which they are attached. How do we counter that argument? And that is where we actually need to have something called control in our experiments. Control is something where you can compare your results with something else. So this is made of iron, and this is probably hypothetically the glue that is going to be tested, and I attach and I make I found out that it is attached. So if it were glue, it should be able to bind to something else too. Here I have a small toy and Minnie Mouse, and I try to put it and even try to press it hard just to see that if there is glue and it will bind, but it doesn't bind. So it would mean that this is a magnet, and it is not because of, or if there is no glue on top of it. My argument could again be that maybe this ring had glue, and that is why this magnet-like thing was sticking to it. So I should be able to test it with something else. And so I take an adapter, say this is a metal, and I'm sticking it, and it will bind to it. If it is magnet, that is how it can work. Or else let me try a coin that I have here, and I can see that the coin is also binding. If we were to continue and have an argument that this also has a glue, I can ask you to bring something that is made of iron, and I can try to test it. So basically we have these the ways of determining, and it's always important to have a control so that we can test how our experiment is right or wrong. Or we have something to compare it with to determine our hypothesis. So for me, in my classes, we say any testing with a control is an experiment. So you have controlled experiments and you have a variable, and because of which when you compare these two sets of observations, you can determine or deduce what is right and what is not. So I think it is important to practice a lot of making observations and thinking of interesting questions about it, and then formulating a hypothesis, and then have some predictions about what could happen if it were, say for example, if it is a magnet, or if it is not a magnet, how could it be tested? And then we experiment, and science is a continuous process. If we fail, then what we thought was magnet could have been something else. And if we are still interested and useful, we find some use of it, or we want to use it, then we have the need to find out what it is, and then we can keep trying to do more and more. So I hope you understood in a simplistic way what is scientific method. We observe, we formulate a hypothesis, we test it, and we report what it is. And we don't need always other people. We can also test ourselves and critique our own observations and our own thought processes while we do these experiments. Thank you very much.